Welcome back. In this video, we're going to talk about equations of lines. We've already talked about the slope-intercept form. Let me pencil that in. That's the y equals mx plus b format in the previous video. Today, we're going to add the point-slope form, and we're going to talk about how to create an equation of a line. Okay, so let's start with the slope-intercept form. We said when it's in this specific format, we have already the slope and this special point, the y-intercept. So if we have that information, we can automatically get the equation of the line and vice versa. The point-slope form is useful if you have the slope, but then you have maybe not the y-intercept, but any point on the line. So m here is still representing the slope. We're going to use x1 and y1 to represent any other point on the line. And we can use that to generate the equation of the line using the point-slope form. So it looks like y minus y1 is equal to m times x minus x1. And both of these are good tools to use to create an equation of a line. So I'm just going to show you a bunch of examples in this video of different types of problems you might come across where you would want to take the clues you have or the information you have and turn them into an equation. Okay, here's the first one. Let's say we want to find the equation of a line that is passing through the point -1, 4 with slope 5. Okay, so we could do it using either of these two tools. I think this time I will use both so you can see what they look like. Okay, so I'll start with the mx plus b format. I already know the slope, so this is my m. So let me go ahead and put that in. To make an equation, when I say equation, I want variables x and y in my equation. So really, the only thing I need to find is the b. I don't have the y-intercept as my point here. If it were 0, 4, then I would immediately know what b is, but it's not. So I need to find it. I need to solve for it. If I use the mx plus b format, what I'm going to do is plug in -1 for my x, plug in 4 for my y, and use that to solve for my b. So let's go ahead and do that. I'm going to put in 4 for y, -1 for the x. This is going to give me -5. To get b alone, I'm going to add the 5 to the other side. Looks like b is 9. I really wanted an equation for my final answer, so now I'm going to take what I got for b and I'm going to put it back into what I had up here. And I want to put my variables back in, again, because I'm looking for an equation. Okay? You can also solve this by using the point-slope form. If you do that, you still have your slope for m. And now we're going to substitute in x1 and y1 as our point into this formula. I'm going to do that over here. It doesn't matter which method you use, you should get the same result. So using the point-slope form, we have y minus y1, which is 4, is equal to the slope, which is 5, times x minus x1. So x minus -1. So these two methods, I feel like they're really not a huge advantage one or the other. The only small differences I can think of would be right now we have an equation. We're just going to make that equation look nice. Whereas here we kind of had to go back and make the equation. I don't really feel like that's a huge benefit. So this is really a personal preference, I think. Okay, I'm going to write my final answer in that mx plus b format. So I'm going to go ahead and distribute my 5. I'm also going to make this subtracting -1 into a plus. That's going to give me 5x plus 5. And to get the y alone, I'm going to add 4 to both sides. Notice we get the same answer with either method. So you are welcome to use either of these methods. I am not going to specify which one you have to use. I'll leave that up to you. For the rest of this video, I'll try and alternate between these two methods just so that you can see them both. Okay, let's try another one. This time, we're going to find an equation of a line passing through these 2 points, -2, 3, and 6, -1. So the two things we need are the slope and 1 point. We definitely have plenty of points, but we don't have the slope. So the first step would be to find the slope. So take these 2 points just like we've done in previous videos, plug them into your slope formula. I'll jot it down here one more time in case you need it. Okay, so we'll have -1 minus 3 over 6 minus -2. So that's going to give us -4 divided by 8, since this is going to become plus. If I reduce that, I'll have -1/2. So my slope is -1/2. Now I want to use one of those two methods to come up with my equation. I don't have any, like I said, I don't have any huge preference, so I'm just going to alternate. This time I'm going to use mx plus b, but if you like the point slope better, go ahead and use that one. That should work just the same. So I need my slope. I also need one of these 2 points. So choose one. Again, it doesn't matter which one. They're both going to give you the same result. I'm going to plug in 3 from my point for the y value. I'm going to plug in my slope for m. I'm going to plug in -2 for my x value. And I'm doing all this because I still need to find the b. So if I multiply these together, this is going to become a positive because they're both negative. I'm going to have 2 divided by 2, which is 1. So if I subtract that 1 over, I find that b is 2. And then remember, I was looking for an equation, so I'm going to go and make my equation. I have my m and I have my b, so I'll have -1/2 x plus 2. Okay, here's another example. Say I want to find an equation of a line passing through the point -2, 1 with slope 0. All right, so maybe you could start to get a hint that this is one that's going to be a little interesting. Maybe you remember what kind of line has the slope of 0? That's no slant, right? Flat ground. So that'd be a horizontal line. Okay, the cool thing about a horizontal line is it still fits in with the mx plus b. Or you could use the point slope. This is our slope, m. So, and 0 is a number, so I can plug in 0 there. So really what I have is, and this is really in general for any point with a slope of 0, 0 times x, no matter what the number is I plug in for x, 0 times anything is just 0. So this is like 0 plus b, which is just b. So this in general is an equation for a horizontal line. And we'll graph this in a second so you can see why that is. Okay, so really we just have to plug in the 1. This feels a little weird. So b is 1. So really our equation is y equals 1. Right, let me draw this in a picture for you, and I think it'll make a little bit more sense. So here's our point, -2, 1. We want to come up with an equation, or maybe we want to just get a visual picture of a horizontal line or a line with slope 0 that goes through this point. So since it's flat, there's no increase. As I run, I do not rise, right? Okay, and here's how I remember which is which, horizontal versus vertical. So if I were to list some points on that line, I definitely have -2, 1, right? But I could pick some other points, like I could pick 0, 1. It's flat, so the y value is really not going to change. I could pick 1, 1. I could pick any x I want, and the y value is fixed at 1. Anytime we have a horizontal line, it's the y value that's going to be fixed, and that's really where the equation comes from. That's kind of what this is saying. The y value is fixed at 1, and x can vary to be any number I want, and that's going to allow that line to stretch out horizontally. Okay, what about a line passing through -2, 1 with undefined slope? All right, if the slope is undefined, we know it's going to be a vertical line. So let's draw the picture first this time. Here's our point, -2, 1. And because our slope is undefined, it must be a vertical line. Let's list some points on that line. For sure we have -2, 1, but we also have this point, which would be -2, 0. We also have this point, which would be -2, -1. Okay, so we could list more. Maybe you can start to see the pattern that this time it's the x value that's fixed. The y value can kind of vary to be anything. So if it's the x value that's fixed, then the equation is going to state that x equals -2 always. There's no y in the equation because y can vary to be anything. There's no restrictions on the y, but it's the x value that's fixed. This one does not fit in with the formats that we've looked at, the slope intercept or the point slope. And the main reason for that is because this line does not pass the vertical line test. So this is not a function. And so the equation has to be written a little bit differently because of that. Okay, the last thing we can talk about in this section is parallel and perpendicular lines. So I wanted to give you an example of each. Parallel lines have the same slope or the same slant. I always think of railroad tracks, right? They're a fixed distance apart, so they never touch each other, but they run in the same direction, which is that slant, right? So we might be asked, we're going to kind of incorporate this into what we were already doing. Find the equation of a line passing through the point 1, 3 and parallel to the line y equals 4x minus 2. Okay, so it's not really, the information that we're given is kind of the same type. We just have to decode it a little bit. We still are going to be given the slope or some information that we can decode about the slope and our 1 point. So here's our 1 point. This parallel to this line, right? This is a clue about the slope. So we want to use the fact that parallel lines have the same slope to get the slope for our new line that we're trying to find the equation of. I always like to break this into 3 steps. So the first step is to find the slope of the given line. Here's the line we're given, right in here in the problem. So what is its slope? This one's already in mx plus b format. And for intermediate algebra, I kind of like to stick with that. I'm going to give it to you in mx plus b format. But when you go on to other courses, right, you're not necessarily going to be that lucky. So you may have to put it into mx plus b format, and that would give you the slope. So here's our m would be 4. That's our slope. Okay, and now we want to find the new slope. We're looking for a new line that's parallel. Since parallel lines have the same slope, our slope's really not going to change this time because they're both the same. Okay, this is kind of, these 2 steps are us decoding this information and to give us the slope. We now have the slope. Now we're going to take this slope and this 1 point we were given up here. That's the only information we haven't used yet. And we're going to do that process we've been practicing throughout this whole video to find the equation of that line. Okay, and again, you can use either, I'll write them both down, mx plus b or point slope. Whichever one is your preference. Because I'm trying to alternate, I'm going to use the point slope this time. Okay, but y equals mx plus b will work just as well. Okay, so I'm going to put in the coordinates for my x1 and y1 and for my slope. So that's going to give me y minus 3 is equal to the slope, which is 4 times x minus 1. And now I'd like to write my final answer to look like mx plus b. So I'm going to distribute my 4. And I'm going to add this 3 over to the other side. Okay, so this is our equation of that line that is parallel to the first one. If we looked back, right, I can't put them both on the screen at the same time, but the slopes are the same and the y-intercepts are different. So they would touch the y-axis in different places, but they would have the same slant. All right, so let's do that same thing, but with a perpendicular line. Perpendicular lines have slopes that are opposite reciprocals. So opposite in sign, and a reciprocal is like a flipped over fraction. Or you could think about it as their slopes multiplying to 1. It's 2 viewpoints. Okay, similar kind of problem where we want to find the equation of the line passing through the point -3, 5. This time perpendicular to the line, y equals -1/3 x. I'm pretty sure this is supposed to be a plus 4. Okay, so again, we want to use this as a clue to find the slope. Same 3 steps. So we want to find the slope of the given line. Here's the given line. What is our slope? -1/3. This time we are looking for a perpendicular line. So we need a new slope that is the opposite reciprocal. Okay, so what is our new slope going to be? This slope is negative, so our new slope is going to be positive, and we're going to flip over this fraction. So +3. Okay, perpendicular lines, I should have drawn a picture, sorry, forgot. Cross each other at a 90-degree angle. So to make that happen, one line is going to be going up and one line is going to be going down. So the line with the negative slope is going down and the line with the positive slope is going up. Okay, once we have our slope and we have this point up here that we haven't used yet, now we can find the equation of the line in step 3. Again, either tool is just as good, whichever one you prefer. This time I'll use y equals mx plus b. Okay? So this time I'm going to put in my x and my y and my m, and I'm going to use that to solve for my b. Please do not think that you have to use mx plus b for perpendicular or point slope for parallel. Remember, I'm just trying to give equal time to both methods. Okay, there's not a specific method for each type of problem. You can use whichever one you like. All right, so I'm going to work this out. I'm going to add 9 to both sides. And then I'm going to go back and make this into an equation. So my slope was 3, so y equals 3x plus 14. I'm not going to graph these for you, but if we did graph them, they should cross each other at a 90-degree angle and be perpendicular. All right, we've given you lots of examples in this video. I hope that you'll take some time to go find some problems to work on your own. Make sure you know how to do this independently so that you're ready for the test. Good luck, and we'll see you next time.